This is Mr. Beck Does Your Homework, AP Physics, homework number 8.3, questions 5 and 6. Gas in a container is at a pressure of 1.7 atmospheres and a volume of 3.1 cubic meters. Atmospheres I'm not too happy of. What is the work done on the gas if it is expanding at a constant pressure to twice its initial volume? Well, now you've got to think about that container of gas you've got, and it's expanding. So if it's expanding, the work done on the gas is going to be negative because you're taking this container, and normally I draw it the other way, but just so I can hold it, I'm going to take this gas, and actually I'm going to be still pushing this way, but the gas is pushing this way. So as I let that thing out, I am doing negative work. So my answer to here is going to be negative, because as this goes this way, that's going to be negative work as it expands. I'm going to do negative work on the gas. So that's the key words there, on the gas, okay? Work done on the gas. Well, my work is going to be my force times my distance, but my force, since pressure is force divided by area, this is going to be pressure times the area times the distance. But this area times this distance is going to be a volume in there, and that's going to be my change in volume. So my work done is going to be my pressure times my change in volume. So it's P times delta V. Since this happens at constant pressure, I am in good shape. So what is the work done on the gas? On the gas means that as it expands, it's going to be negative work at constant pressure to twice its initial volume. So actually, when you do this equation, it's work done on the gas is negative P delta V. So my delta V in this case, since I'm doubling the volume, I start at 3.1, I'm going to go to 6.2. So my delta V there is going to be 3.1. But my pressure here, the pressure that's going to be constant is 1.7 atmospheres. Well, I don't like atmospheres. I'm going to have to multiply that by 101,300 in order to get pascals. So that's my pressure in pascals is 1.7 times 101,300. So I'm going to take that pressure times my delta V. Since I've got 3.1 and I'm doubling it, it's going to be a delta V of 3.1. And that's in meters cubed, so that's good. So my work is going to be negative whatever that product is. So there's my work done on the gas. The second one says, what is the work done on the gas if it is compressed at constant pressure to 1/5 of its initial volume? So I start with an initial volume, which is 3.1 meters cubed, and I'm compressing it down to 1/5, right? So now it's 1/5 is what I'm left with. So that means that it's compressed. This is going to be my delta V. My delta V is going to be the rest of it. That's going to be 4/5 of my original 3.1. So I had 3.1 total. I compressed it down to 1/5 of that. That means my delta V was 4/5 of that. So my delta V is going to be 4/5 of my initial volume. So my delta V is 4/5 of 3.1. So again, it's at the same pressure, so this pressure will still apply, but now my work is going to be negative of that same pressure from up here times whatever 4/5 of 3.1 is. So I'll just say delta V, and that will give me my answer for the second one, and it's going to be a negative number. Nope. I take that back. It's negative that, but my delta V is going to be negative because it's losing that, right? So it's losing this. So this is going to be a delta V. This delta V should be negative. So I'm losing 4/5 of it. So I'm losing that much. So since this delta V is going to be negative, this number in the end is going to wind up being a positive number because this is negative and this is negative. So this is positive, but this negative sign in the equation is going to knock out the negative there. So I'm going to do positive work here. So this answer is going to be positive work because I'm compressing it. This answer is going to be negative work because I'm letting it expand.